How do railroad tracks show parallel lines and transversals? Imagine standing on a train platform and looking down the tracks. Do you notice how the two rails run side by side without ever crossing? That's because they are parallel lines. Railroad tracks are a perfect example of parallel lines because the two rails stay the same distance apart all along their length. They never meet or cross, no matter how far they go. This consistent spacing is what makes them parallel. Now, when a road or a path crosses these tracks at an angle, it acts as a transversal. A transversal is simply a line that intersects two or more lines at different points. In this case, the crossing road cuts across the two rails at an angle, creating a series of angles at each intersection. These angles follow specific rules. For example, the angles that are in the same position at each crossing are called corresponding angles. These angles are equal in size. Then there are alternate interior angles, which are inside the rails but on opposite sides of the crossing line. These are also equal. Outside the rails on opposite sides of the crossing are alternate exterior angles, which are equal too. Lastly, there are co-interior angles, which are between the rails and on the same side of the crossing. These angles add up to 180 degrees, making them supplementary. When you see a road crossing railroad tracks at an angle, the angles formed at each intersection follow these rules. This helps us understand that the rails are parallel because these angle relationships only happen when lines are parallel. So, in real life, railroad tracks show parallel lines because they stay the same distance apart and never meet. The crossing road acts as a transversal, creating angles that follow specific rules. These angle relationships are proof that the rails are parallel. This example makes it easier to see how parallel lines and transversals work together in geometry. It's a simple, real-world way to understand some of the most important ideas in geometric theorems and proofs.